Optimization is tough. So here we go. Cost function, we talk about C of x. I want to talk about average cost. Suppose it costs me $100 to produce shoes, and I produce 20 shoes. How much does it cost me to produce each pair of shoes? $100 cost me $100 to produce 20 pair of shoes. How much does it cost to produce each pair of shoes? 5, right? You took the cost and you divided by the number, right? So average cost function is the cost of producing X items, and then we divide it by the number of items, and the number of items is X. You okay with that? The marginal cost function we've already talked about, okay? I'm producing shoes. I produce the first pair of shoes. It cost me like $25 to produce the first pair of shoes because I'm not very efficient. But all of a sudden, then later on, after I produce my 100th pair of shoe, I'm down to like, say, $5 per pair of shoe because I'm better at it. I'm faster. I have everything set up, right? That's called the marginal cost function. We've already covered that in a previous section. That's C prime of x, simply the derivative. Wouldn't you agree that in business, it's great if the average cost is as low as possible? We would like to minimize that. How do we minimize something? Take the derivative and say equal to 0. What formula do you think we would use to find the derivative of C of x over x? The quotient rule. Good. Super easy. Derivative of C of x. C prime. Times what? X minus derivative of the bottom, 1, times the top, all over x squared. We're going to set that equal to what? 0. I'm going to use this to come up with a really, really nice expression. Really nice expression. If I cross multiply, what's x squared times 0? 0. And you get 0 equals C prime of x times x minus C of x. Watch what happens if I add this over. I get C of x is C prime of x times x. Did we already write something like that down on the board? What's C prime of x stand for? My marginal cost function. But it's times x, isn't it? I'm going to divide it by x. And I get C of x over x is equal to C prime of x. You just told me that C prime of x is what? The marginal cost function. What is C of x over x? The average cost. Turns out that in economics, average cost is minimized when the average cost function is equal to the marginal cost function. This formula and these formulas you'll get to use on your test. Just know, I'll give them to you, just know how to use them, okay? C of x over x is equal to C prime of x. Okay, let's look at the first problem on your assignment. We'll do that together. You'll be able to take care of the other two, no problem. It says for each cost function, find the cost, the average cost, and the marginal cost at the production level of 1,000 units. We are given the cost function. Anybody want to guess how we figure out the cost of 1,000 units? We plug it in. So we're going to start for letter A by finding C of 1,000. I'm going to go to my calculator and I'm going to type it in there. In fact, I'm going to go into my y equals, get rid of my plot, and go 40,000 plus 300x plus x squared. And once I've got that, I'm going to go into my table. Thank you. And I type in 1,000. And when I do that, I get this. Now, if you go over and highlight it, it'll list the number right there. It looks like I get the cost of producing 1,000 items is $1,340,000. Is everybody okay with the first step? The second step is to find the average cost. The way that we find average cost is we take the cost and we divide it by what? And what is X? How many items have we produced? 1,000. So you're going to take the total cost and divide it by the number of items. We produce 1,000 items, so that means that the average cost is going to be $1,340. Right now, its cost is $1,340 per item that we make. Well, it depends. Like, for example, if we're making shoes, we're probably not very efficient right now, right? If we're making aircraft carriers, wow, we're doing a good job. Okay, so it really depends on what we're producing. And it says the marginal cost, that means the cost to produce the next item. How do I find marginal cost? Take the derivative. What's the derivative of that guy? 300 plus 2x. So that means that C prime of 1,000 is equal to, if I plug in 1,000, I get $2,300. So the cost of producing the next item is currently cost is $2,300. So that, you know, the average cost is lower than the marginal cost, isn't it? That means that we're running into something right now where it's costing us more money. Who knows? It might be the demand of what we're trying to produce. Who knows? Oh, sorry. Thank you. I'll probably show up. Yeah. Part B, the production level that will minimize the average cost. We just had a formula. What was our formula for minimizing average cost? C over x, C of x over x is equal to C prime of x. Let's try to figure that out. What is C of x? $40,000 plus 300x plus x squared over what? X is equal to what's C prime of x? $300 plus 2x. I want to solve that equation. What do you think I should do to solve that equation? Cross multiply. We get 40,000 plus 300x plus x squared is equal to 300x plus 2x squared. What do I do? Yeah, if I subtract 300x from both sides, what's going to happen? Isn't that nice? Move the x squared over, I would get 40,000 is equal to x squared. Now what? Square root both sides. What's the square root of 40,000? I subtracted the x squared over there. 2x squared minus 1x squared is x squared. What do you get? X is 200. So if we produce 200 units, we will minimize our average cost. The final question is, what is the minimum average cost? This is where people make mistakes on the test. Okay? The minimal average cost. First, let's figure out the cost of producing 200 items, and then let's divide it by 200. I'm going to use my calculator to help me out. Do I know the cost of producing 1,000 items? Could I find the cost of producing 200? Yeah, it looks like it's 140,000. What am I then going to do with that 140,000? Divide by 200. So if you take 140,000, you divide by 200, you just get 700. We don't just want to minimize average cost. We want to maximize profit. That's going to require us to think about how we generate money. Can somebody tell me what's the difference between revenue, cost, and profit? What is that idea? How do we understand how they relate together? Revenue, cost, and profit. Anybody? Revenue is how much I get. Cost is how much I spend. Profit is revenue minus the cost. We good? Okay, so profit function is equal to the revenue function minus the cost function. Everybody good with that? Okay, so the revenue function we're just going to call R of X. But we need to think of how we get R of X. This is the one thing that's tricky for people to understand, okay? And it's not that bad, okay? What do you want to buy from the grocery store? Pizza, she wants to buy frozen pizzas, okay? They cost $5 each. $5 each. How many do you want to buy? 2. She wants to buy 2 frozen pizzas. How much revenue does the store make? $10. Everybody agreed? You took the price and you multiplied it by the number of items you purchased. So what do you think I multiplied by? X. So revenue is X times your price function. Now, notice that I put price as a function because right now it's $5, right? But it turns out if you went to the store and you said, hey, I'm going to buy 2 pizzas, they're like, well, $5 a piece. You said, no, I'm sorry, I'm going to buy 2 crates of pizzas, right? And be like, okay, you're going to buy 2,000 pizzas. We'll give it to you for like $2 a piece or something, right? Like, so that might drop depending on the situation. Agreed? So if you want to come up with the revenue function, take the number of items times the price function. The marginal revenue function is just R prime of X. And the marginal profit function, that's what we want to be able to determine. I want to maximize profit. Profit function is equal to R of X minus C of X. Profit is equal to R of X minus C of X. I want to maximize it. How do we maximize things? Take the derivative and set it equal to 0. The derivative of your profit function is P prime of X. The derivative of your revenue function is R prime of X. The derivative of your cost function is C prime of X. Hey, we're going to take the derivative and set it equal to what? 0. 0 equals R prime of X minus C prime of X. Hey, anybody think of a nice way to write that? If I just add the C prime over, yeah, C prime of X equals R prime of X. When does maximum profit occur? When the marginal cost is equal to marginal revenue. So that's the last formula we'll write down. C prime of X is equal to R prime of X. When those are the same, you maximize your profit. Take out your worksheet and flip it over to the back side so we can try one of those kind of problems together. For the given cost and demand functions or price functions, price and demand, we're going to say the same things. Find the production level that will maximize profit. So what I like to do in this situation is I like to first identify what my cost function is. Do we know what the cost is? Yeah, it's that guy right there, right? I need to come up with a revenue function. Revenue function is equal to X times your price function. What's my price function? 12. Yeah, it's just a constant. It's kind of like Lauren said she's buying pizzas, they're $5 a piece, and it's not changing, okay? So, therefore, R of X is equal to 12X. Is everybody clear how I got that? That's the only thing that's confusing. What's our goal with the problem? What's the goal of the problem? Maximize profit. Maximum profit occurs when R prime of X is equal to C prime of X. Do you know how to find R prime of X? What's R prime of X? 12. Do you know how to find C prime of X? What's C prime of X? 4 plus 0.02x. Can we solve that? Yeah, we get 8 is equal to 0.02x. We divide by 0.02. Anybody? X is equal to 400. Find the production level. We produce 400 units. That will maximize our profit. Pretty straightforward, right? Guys, I just wanted to show you why it sets up as R prime of X equals C prime of X. That's why I took you through this just brief reasoning, right? Well, I'm sorry, on the other notebook that I was bringing it through. I mean, this is that's pretty basic, right? See how we got from one step to the other? That's why it works out. So now you can do problems 4, 5, and 6. Don't worry about 7 and 8. We're going to open class on Monday with those. They're easy. Don't have to worry about it, okay? There you go.